Hi guys. Right, today we're going to look at rotating shapes, and obviously I can take a shape and I can rotate it through an infinite amount of angles until I get to 360 degrees, but really what we need to be concerned with at our level is about rotating through 90 degrees, that's a quarter turn, 180 degrees, a half turn, 270, which is a three-quarter turn, and 360, which is a full turn, so which should take us back again to where we were. There's two directions. The directions that you should be really familiar with is clockwise and anti-clockwise. And I shall just have a recap here. 90 degrees is a quarter turn, 180 degrees is a full half turn, 270 degrees is a three-quarters turn, and 360 degrees is a full turn all the way back to the beginning again. Obviously we can do those in both directions, clockwise and anti-clockwise. You'll find that in maths in general we work from this horizontal axis and work anti-clockwise in nearly every case. There's only something called bearings where we do something different. Right, so I'm going to start off with this one. I want to rotate shape, I'm going to call that shape A. I'm going to go for rotate shape A 90 degrees anti-clockwise. Now the piece of really sophisticated equipment I'm going to use is this. Now you might think I've got a piece of tracing paper, but actually I haven't. I've raided my baking box and I've got a piece of greaseproof paper, and that will do the job just as well. So you can see when I lay it over the top I can see straight through it, and that's going to really help me. Now what I'm going to do is I'm going to draw my shape underneath my greaseproof paper. And I'm also going to draw my axes. There. Because that's going to really help me so much. Because if I need to draw by 90 degrees, I can fit the axes back out onto themselves again, and that'll show me the turn. So that drawing that cross on the axes is really essential. Now you can do this with a piece of plain paper. You should be able to see through it enough. But a piece of baking paper or a piece of tracing paper is perfectly good. Right, I'm going to rotate anti-clockwise. There's something I haven't said. I'm going to say about O. Now O stands for the origin, and it's the point 0, 0. So we always get told a point to rotate about. And I'm going to look for a sharp piece of paper, sharp pencil. So I'm going to go 90 degrees. So that means I fit the crosses back onto themselves and back in again. And it ends up just there. And I'm going to press in. Hopefully I'll be able to see an indentation on that paper, which I couldn't. I'll try something a bit harder. And I can just about see those. And that gives me a reflection. Sorry, a rotation. It is just about here. Just need to check whether that's right. Actually, it should be down a bit, I think. So it should be there actually. Now there's some things I need you to notice. For example, if I were to look at this point here, I go 1, 2, 3, 4, 5, 7, 8, 9, 10 across and 4 up. And I make a little L shape there. Now, if I rotate that actual L and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 2, 3, 4, I end up to the right place. And if I looked at a different one, so say I was to look at this one, I can see that that's 4 and 4. If I rotate that L, so I go 4 and then 4, I end up here. So you can see that there is a bit of a different way of doing it. If I wanted to see where this 180 degrees was, I could say, right, I could go 10, 4 to there. So I need to go 10, 1, 2, 3, 4, 5, 6, 7, 9, 10. 1, 2, 3, 4. And then this one would come 4 and 4 again. 1, 2, 3, 4, 2, 3, 4. So already I've got that drawn like that. This point here is 4 along and 5, 6, 7, 9, 10, 11. So 4 and 11 would go 4 and 11, 5, 6, 7, 8, 9, 10, 11. So I would draw it there. So my red one, once I got it in the right place with my thick pens, that would be A dash, that's a rotation. And 90 degrees, and this one would be a rotation 180 degrees. 180 degrees is really useful because you don't have to consider direction. If I went that way or if I went that way, I'd still end up in the same place. That would be called a different name. Now, we don't always rotate about O. So if I got a different shape and I had to rotate about a different point, so say you asked me to rotate this one 180 degrees about this point here, what I might be tempted to do is to draw myself a little mini set of axes. Because then when I went over the top of it, it would be easy for me to know when I was going through 180 degrees, so a half turn. So I would just have to go like that. You can see that it would end up down there somewhere, and there obviously I need to make an impression to see where it is. So there, this one would be there somewhere. There, and there. So that would help me redraw again. So here, if this is triangle B, this is B dashed after a rotation of 180 degrees. And we would normally say about, now where is this point I've gone about? 1, 2, 3, 4, 5, 6. 6 along, 0 up. So that's what that point is. So the centre of rotation. And that's the point 6, 0. Okay? So, just to summarise, a bit of greaseproof paper will help you do these, because it'll help you know whether you've turned over 90 degrees, 180 degrees, 270 degrees. It's really, really helpful. If you come to a different place when you think about that centre of rotation, draw a cross on, like a new set of axes, which you can draw over the top, because then you can see again about how to turn 90 degrees, 180 degrees, etc. Bear in mind we can go clockwise or anti-clockwise. Maths is generally anti-clockwise, but we can go in either direction. So that's about all I wanted to show you. Okay, thank you.